Welcome back. In this video, we're going to look at bearings, the two different types of bearings, true bearings and compass bearings. But more importantly, when the word bearing appears in a question, how do we solve it using our trigonometric ratios? Well, stay tuned. We're going to look at a couple of examples. Okay, bearings. What are bearings? Well, bearings use compass points to express any direction of travel. It's really important to know that bearings tell us the direction, they don't tell us a distance. Two types of bearings we want to look at today. They are true bearings and compass bearings. So let's start with what we call a true bearing. Now, true bearings have three rules. Rule number one, it must start from north. So I have a compass point here and I have my north, south, west and east. Whenever I'm doing a true bearing, I have to start at north. Rule number two, it has to go in a clockwise direction. So remember, this is anti-clockwise, we want to go clockwise. And rule number three, it must be three figures. Well, that means if I've got a bearing of 40 degrees, I've got to put the 0 in front. So it will be 040 degrees. What we tend to do with true bearings is put a capital T at the end of it, and that shows it is a true bearing. Okay, the second type of bearing is a compass bearing. Now, a compass bearing is very similar, but there's one additional rule to this. Compass bearing still has compass points, my north, my south, my west, my east. My compass points this time, I must start reading the bearing from either north or south. I don't have just a clockwise direction, I can go either clockwise or anti-clockwise, and my angle must be between 0 and 90 degrees. So for example, looking at this, if I want to find the bearing of A from O, let's start with a true bearing. Remember, I start at north, I go clockwise, and I go around until I hit the ray that O is on. And as you can see, it's 120 degrees. Now, I don't really need to put a T on the end because it is a three figure. So I can just say 120 degrees T or 120 degrees and people will know that's a true bearing. But what if I said what is the compass bearing of A from O using this same example? Well, remember this time I've got to find what two compass points it falls between, and I remember I have to start at either north or south. Well, it's nowhere near north, so I have to start at south. I'm not going actually I'm going anti-clockwise because my ray is in the opposite direction. So as I go anti-clockwise, I need to go until I hit ray A, and as you can see, it's going to be a 60-degree bearing. So to write this one, we would write south 60 degrees east. Same picture, two different bearings, a true bearing and a compass bearing. Now we have a lot more examples and you can actually click or subscribe and we can give you some more examples on bearings. But why don't we go ahead and see how are these bearings used in worded problems and how do we use our SOHCAHTOA to actually find distances? Well, let's do an example where we have the word bearing in the question. Let's have a look at this example. It actually says a bushwalker walks 4.2 kilometres on a bearing of 42 degrees from a point A to a point B. Question, how far east has he walked? Well, the most important thing is the word bearing was said in the question. So the minute I see that word bearing, I need to draw a compass. As I draw my compass, let's put on the north, the south, the west, the east point. Okay, reading the question again. I'm a bushwalker and I'm walking 4.2 kilometres on this bearing. Well, it's 42 degrees, so I'm going to start from north. I'm going to go all the way around to a 42-degree angle and I'm going to draw a line which we call a ray and label that line 4.2 kilometres. Now, the question is how far east? So looking at my compass point, I need to draw my horizontal line in so I can create my right angle triangle. We don't know how far east we are, so why don't we label that as X? That's my unknown. Now, as you can see, we're going to have a right angle triangle. We have an angle, we have an opposite, and we have a hypotenuse. So remembering from my earlier lessons, from my SOHCAHTOA, which one has the opposite and the hypotenuse? Sine, that's it. Sine equals opposite over hypotenuse. So setting up the equation, we have sine 42 is equal to my opposite over hypotenuse, which is x over 4.2. Going all the way back to lesson 2, when my unknown is on top, it's really simple. I just have to multiply the denominator up. So 4.2 times sine 42, punch it in my calculator, and I'm going to get an answer of 2.8 kilometres. Well, what does that mean? That means if I walked 4.2 kilometres on a bearing of 42 degrees, I actually walked 2.8 kilometres in an easterly direction. That's it. Once you see the word bearing in a question, draw your compass point and follow all your SOHCAHTOA rules to apply your trig ratio equations and then solve them. I hope you enjoyed what you saw. Stop. Okay. I hope you enjoyed this video. Don't forget, click on the like button and subscribe to the channel if you're interested in more content. And if you'd like some free worksheets with full work solutions, all you have to do is click on the link of the description of the video. I hope that helps. See you soon. So corny.